The year was 1905. Albert Einstein had just discovered general relativity. This is one of the most crucial theories alongside quantum mechanics in the 21st century. It had always been Einstein's dream to link the two, and this bridge would allow us the opportunity to understand every single thing in our universe at every scale. So, let's take a journey in understanding the basic fundamentals that make up the closest theory in history to uniting the two, commonly known as the theory of everything. There are four forces: electromagnetic force, strong force, weak force, and gravitation. Three of these four forces can be shown using the Standard Model. Let's take a look inside an atom to show how the strong force affects the nucleus's structure. We are now going to look at the atom. In the center of every atom is the nucleus. As we enlarge the nucleus, we can see a pair of protons and neutrons. Now, these protons and neutrons are held together by strong forces. Let's look into what the particles are made up of by peering inside of a neutron. Inside of this neutron, we can see three little particles known as quarks, which are so far the smallest particles known in the atom. According to the string theory, these quarks are made up of tiny little things. The string theory is the closest to ever unite the fundamental interactions of nature. These so-called things that make up the forces are the smallest particle ever imagined, a billionth of a fraction of an atom. They are known as strings. There are two main ways a string can be presented: an opened or a closed loop. These strings are able to vibrate, which is what gives them so many different abilities. Much like the cello, every string has its own frequency and purpose. These vibrations give particles like quarks all their qualities, including charge and mass. So how is it that strings are able to relate quantum mechanics and general relativity? Let's take a look. We have two models showing the main structure of each theory: a small scale and a larger scale. Both scales should have the same overall movement, but it's evident that that is not the case. The two represent the theories which could not be linked together due to the completely opposite movements. Once strings are inserted into the small scale, it calms it down just enough to be able to link both scales. This shows that strings are the key component to building a bridge between both structures, and thus fulfilling Albert Einstein's dream of uniting both theories. So why care for something so small, something we can't even see? Because general relativity and quantum mechanics are no good to us separated, but if united, we will be able to answer questions we deemed impossible. Topics ranging from a black hole to gravity at the quantum level, even the birth of our universe. String theory is the next step in uniting quantum mechanics and general relativity. I want to leave you with this. According to string theory, there is a string in every single point in space. And as we know, each string has its own vibration, that of which resembles a music note, thus making our universe a grand cosmic symphony.